Welcome to the lecture series on material testing and construction practices. Today's topic of discussion is bricks. Bricks are obtained by molding clay in rectangular blocks of uniform size and then by drying and burning these blocks. As per IS 2248-1992, a brick is defined as a masonry unit not exceeding 300 mm in length, 150 mm in width, nor 100 mm in height. The composition of a good brick earth. A good brick earth should contain these materials in these particular proportions. The compositions are as follows: alumina 20 to 30%, silica 50 to 60%, lime not more than 5%, magnesia less than 1%, and iron oxide 5 to 6%. Here you can see some pictures of the brick manufacturing processes involved. The first picture involves the drying of these clay bricks, and then these particular bricks are stacked, and these are the controlled burning or drying, or you can call. And here you can see the figure of burning the bricks, because of which ultimately the chemical reaction takes place and the brick gets its characteristic and the properties because of this particular, especially the burning process. The types of bricks. Bricks are classified as conventional or traditional bricks and standard brick. Conventional bricks, the dimensions are 23 cm by 11.4 cm by 7.5 cm, and the standard brick is 19 cm by 9 cm by 9 cm. All the dimensions are in centimeter, the above dimensions, and you can see this indentation at the top. This is known as frog, and the size of frog is 8 centimeters by 4 centimeters by 2 centimeters. The qualities of good brick. Bricks should be table molded, well burnt and cleansed, copper colored, free from cracks, with sharp and square edges. Bricks should be uniform shape and should be of standard size. Bricks should give clear ringing sound when struck with each other, and bricks should not absorb water more than 15% by weight for first class bricks and 20% by weight for second class bricks when soaked in cold water for a period of 24 hours. Bricks should have low thermal conductivity and they should be soundproof. Bricks should not break when dropped flat on hard ground from height of about 1 meter, and no brick should have a crushing strength below 55 kg per centimeter square or 5.5 Newton per millimeter square. The bricks are classified as follows. The bricks are classified into two broad categories, that is unburnt bricks or the sun-dried bricks and burnt bricks. Burnt bricks are further classified as first class bricks, second class bricks, third class bricks and fourth class bricks. As per IS 1077-1992, the common burnt clay bricks shall be classified on the basis of average compressive strength as given in table 1. So as per IS 1077, the bricks are classified into these class designation, and these class designations are computed as per the average compressive strength of the bricks after conducting the compressive strength on the brick sample. The class designation to that brick sample is designated. Now coming on to the composition of good brick. The composition of good brick earth consists of the following components. First is the alumina. A good brick earth should contain 20 to 30% of alumina. Alumina imparts the property of plasticity to the earth. An excess of alumina causes shrinkage and warping of bricks during drying and burning, and it becomes too hard when burnt. The next component is silica. It is seen either in the free or combined form. In the free state, it is mechanically mixed with clay, and in the combined form, it exists in a chemical composition with alumina. The cracking, shrinking and warping of raw bricks are being prevented by the presence of silica. The durability of bricks depends upon the proportion of silica. An excess of silica destroys the cohesion between particles and the bricks become brittle. The next component is lime. Lime is both desirable and non-desirable. It is desirable in good brick earth. Lime prevents shrinkage of raw bricks. The sand is infusible but is slightly fuses at kiln temperature in presence of lime. The excess of lime causes the brick to melt and hence its shape is lost. The lumps of lime are converted into quick lime after burning. This quick lime slakes and expands in presence of moisture, and such an action results in splitting of the brick into pieces. This phenomena is known as lime bursting. Oxide of iron. A small quantity of oxide of iron to the extent of about 5 to 6% is desirable in good brick earth. It helps as lime to fuse sand. It also imparts red color to the brick. The excess of oxide of iron makes the brick comparatively less. The bricks will be of yellowish color. And next is magnesia. A small quantity of magnesia, that is less than 1% in bricks earth, imparts yellowish tint to the brick and it decreases shrinkage, but excess of magnesia leads to the decay of bricks. Now coming on to the harmful ingredients of brick earth, the first component is alkalis. Alkalis present in the brick earth lower the fusion temperature abnormally, making the brick deform and twist. In addition, alkalis have hygroscopic properties. They absorb water from atmosphere and make the walls damp, resulting into unhealthy atmosphere, weaker structure. And these alkalis also causes the phenomena of efflorescence, which is a defect in brickwork. The next harmful ingredient is lime. As we have already seen, lime is both useful and at the same time it is harmful. If these are present, as explained earlier, on heating gets converted to quick lime, and this quick lime in the presence of water is highly brittle and the brick crumbles. The next is iron pyrites. If iron pyrites are present in the brick earth, the bricks crystallizes and disintegrate during burning process because of the oxidation of iron. Now coming on to the next harmful ingredient is pebbles or the grits. In the presence of these, there is hindrance in molding of brick. In addition, the brick cannot be cut to the required size if needed while erecting the wall. The vegetation and organic matter present in the brick earth, they are the harmful ingredients, and that's why we remove the topsoil, which is not good for the manufacturing of the brick. But still, the vegetation and organic matter present in the soil, they hamper in the proper molding of the bricks. The organic matters like roots, leaves, etc. burn during the brick and the gas is produced. This carbon dioxide creates porosity in bricks, affecting the strength of bricks. Hence, organic matter should be avoided in brick earth. Now coming on to the manufacture of brick, it involves the following process. That is, first is the preparation of clay, then molding of bricks, then drying of bricks, and lastly the burning of bricks. The preparation of clay. The preparation of clay involves unsoiling, followed by digging, then cleaning, after cleaning, then weathering, blending, and lastly tempering. And this is how the plastic clay mass is produced for the molding of the bricks. Unsoiling. The top layer of the soil is taken out. This is because the clay in the topsoil is full of impurities and hence in top layer it is rejected for the purpose of preparing bricks. Second is digging. The clay which is dug out is spread on the ground level, just little deeper than general ground level. The height of the heap of clay is about 60 to 120 centimeters. Cleaning. The clay should be made free from pebbles, stones and vegetables, that is organic as well as inorganic impurities. If these particles are in excess, the clay should be washed and screened, which is considered to be uneconomical. Weathering. The softening of the clay is done by exposing it in the atmosphere. The period of exposure varies from weeks to full season. Next is blending. The clay is made loosened and any ingredient to be added is spread out at the top. The blending indicates intimate mixing. A small portion is taken out every time for the mixing. As we have already seen the definite composition of a good brick earth, if any component is lesser, we can go on with the blending process. Then we have the tempering process. In this stage, the clay is brought to a proper degree of hardness and is made fit for molding. Water in required quantity is added and the whole mass is mixed so as to form a mass of uniform character. A large scale tempering is usually done in a pug mill The process of grinding clay with water and making it plastic is known as pugging. In this figure, you can see this is a pug mill, large scale tempering of brick earth in order to produce the tempered clay mass. Pug mills are utilized, and large quantities of soil can be obtained through this pugging process. Now, after the plastic mass has been created, that is, the soil has been prepared, the desired degree of plasticity has been achieved. Now we move on to the next process, that is the molding of bricks. Molding is the process of making rectangular shaped units for properly tempered clay. There are two types of molding are involved. One is the hand molding and the other is the machine molding. Hand molding. For brick manufacture, this is adopted where manpower is cheap and readily available. The molds used for hand molding are rectangular boxes made from well-seasoned wood or steel, open at the top and bottom. Types of hand molding: ground molding and table molding. Ground molding. In this method, the ground is first leveled and fine sand is sprinkled over it. The mold is dipped in water and placed over the ground. The clay is pressed in the molds in such a way that it fills all the concerns of the mold. Any surplus earth from the top of the mold is removed using cutting wire or metal. The same mold can be used for other also, so that wastage can be avoided. Next is the table molding. The process of operations are carried out on a specially designed molding table. The clay, the mold, water pots, stock board, etc. are placed on this table. The bricks are molded similar to the ground molding on the table. The cost of brick increases when the table molding is adopted, but the quality of the bricks that will be availed in table molding will be much better as compared to the ground molding. Now coming on to the machine molding. It is economical when bricks are produced in huge amount. This molding can be achieved by using machines. It is quite economical, and at the same time, if we want to produce a smaller number of bricks, then this proves to be costly. But the quality of the bricks that will be available from machine molding will be very good, because the quality control is a much controlled in this particular condition. And plastic, there are two kinds of machine molding: plastic clay machine and the dry clay machine. Plastic clay machine, these machines containing rectangular opening of size equal to the length and width of the brick. The pugged clay is placed in the machine, and as it comes through the opening, it is cut into strips by wires fixed into frames. So it is known as wire cut bricks. Here only the one problem is there, that froth cannot be created in these kind of bricks, but the surfaces and the corners will be very smooth and sharp. Dry clay machines. In these machines, the strong clay is first converted to powder form. A small quantity of water is added to stiff plastic paste. Such paste is placed in mold and pressed by machine to form well-shaped hard brittle bricks. These bricks are known as pressed bricks. This machine mold bricks have regular size, shapes, edges and corners, and they are heavier and stronger than the hand molded bricks. Now next, after the bricks have been molded, now these molded bricks will be dried. The next operation is the drying operation. The drying of bricks is necessary, firstly to make them strong enough for rough handling during subsequent stages, and secondly to save fuel during burning. For drying, the bricks are laid to longitudinally in stock of bricks with width equal to 2 bricks. The important facts to be remembered while drying bricks are as follows. The bricks are generally dried by natural process, but when bricks are to be rapidly dried, the artificial drying may be adopted. In artificial drying, the bricks are made to pass through dryers in the form of tunnels or hot channels or floors. The bricks in stocks should be arranged in such a way that sufficient air space is left between them for circulation of air. The period of drying bricks depends on the prevailing of weather condition. Means it is dependent on the prevailing weather conditions. Now last process is the burning process, which is the most important process. The burning of dried bricks are essential to develop the desired engineering properties like hardness, durability, and resistance to decay. The chemical changes are known to take place in the brick earth, namely dehydration, oxidation, and vitrification. Dehydration is completed within 425 to 750 degrees centigrade temperature range, and it results in the expulsion of most of the water from the bricks. Vitrification is an extreme reaction and occurs when heating is carried out beyond 900 degrees centigrade. Now, burning is either done in clamps or kilns. The shape of the clamp is generally trapezoidal. The brick is constructed on the short end and a layer of fuel is placed on the prepared floor. The fuel generally used are cow dung, litter, husk of rice, coal, wood, etc. And the thickness of the fuel layer varies from 70 to 80 centimeter. The layer consisting of 4 to 5 courses of raw bricks is then put up. Sufficient space for air circulation is provided, and the clamp is then allowed to burn for 1 or 2 months, and the cooling is also to be done for 2 months, and later the burnt bricks are taken out. Means if you have to burn the bricks in a clamps, it is a one-time affair, and then if you want to avail the next lot, you need to set up another clamp, which will again take the same kind of time. Now coming on to the kiln burning, the kiln used for manufacture of the bricks are of two types: intermittent kilns and continuous kilns. Intermittent kilns, these kilns can be underground or overground in the model. They are classified into two ways: intermittent updraft kiln. These kilns are in the form of rectangular structure with thick walls outside. Doors are provided at each end for loading and unloading of kilns, and the flues, gate, channel or passage which are provided to carry flames or hot gases through the body of the kiln. A roof is provided to protect the raw bricks from rain. The quality of brick is not uniform. The bricks at the bottom are overburnt and at the top are underburnt. Intermittent kiln. These kilns are rectangular or circular in shape. They are provided with permanent wall and a closed tight roof. The floor of the kiln have opening which are connected to a common chimney stacked through the flues. Here you can see the plan of intermittent kiln. And then coming on to the continuous kiln. These kilns are continuous in operation where loading, firing, cooling and unloading are simultaneously carried out. The first category is the bull's trench kiln. This is a continuous type of kiln. These kilns are circular, rectangular or oval in shape in plan. These kilns are constructed in trench excavated on the ground. It may fully be underground or partially projecting above the ground. The outer and the inner walls are to be constructed in bricks. Hoffman's kiln. These kilns is constructed underground, is circular in plan and consist of number of chambers. A permanent roof is provided so that the kiln can function even in the rainy season. So that's all on this particular video on bricks. Thank you for patient hearing. Thanks.